Hi everyone. Today we're gonna come to section 3.4, the chain rule, and I'm gonna talk I'm gonna have something from section 3.6, derivative of logarithm. So let's start with an example over here. We want to take the derivative of 2x, everything to power 3. If I follow by the power rule, so if I follow power rule, how can I handle this problem? Okay, so here's say case A, right? If I follow power rule, I have put down number 3 and then multiply by 2x to power 3 minus 1, which is 2, right? So what is that going to be equal to? I have 3 times 2 to power 2 times x to power 2. If you try to extend the square, the power, right? Now simplify the constant. I have 3 times 2 to the power 2 going to be 4, right? And 3 times 4 going to be 12. And then times x to the power 2. So that should be answer if you follow the power rule. What about another case if I say I want to do multiply first? Multiply first. And then I do differentiate. So I have f equal to 2 to the power third times x to the power third. So I just wanna multiply the power inside. I put the power inside of the extend the power, this power 3 into 2 and x first and see what happens, right? So I'm gonna have 2 to the power third gonna be equal to 8 times x to the power third. That is just for f of x. Let me see. So now I'm gonna do the derivative of this. That's gonna be equal to 8 times 3 times x to power 3 minus 1 equal to 2. And that's gonna give me equal to 22 x squared. So compare, let me circle this and this. This is when I try to do multiply first and then differentiate, right? So if you compare to this answer, you can see that they're different and they're not much, right? So I expect them, I expect that they have to be the same, but they don't match. So what's going on? actually, in this case, the answer, the correct answer, it should be this guy. Okay, because when you do multiply first and then you differentiate, it should be okay. But for the first one, for the first case, if you just follow by the power rule, it could be wrong because the power rule usually apply for the case that the inner function over here should be, you know, just an x, right? Not, it doesn't have like like a like um combine things here, right? So so in this case, if you apply the power rule that we have learned, it should be wrong. Okay, wrong answer. And what we should do in this case, you may use multiply first and then differentiate, but later on, if you have so many complicated things, that should not be a good idea. So what we need to do in this case is we need to use chain rule. Okay. Okay, so let's have suppose that you was asked to differentiate fx equal to square root of x squared plus 1. So how can we do this one? We do not yet have tools for do this at all, right? Even if you use if you use, try to multiply first, it doesn't work, right? So there is only one way, which is chain rule. And what is that going to be? We let's come back to the function composition. We can write this function to be like as a function composition, such as let f of x equal to square root of x, and then g of x equal to x squared plus 1. So the capital F of x will be the composition of f and g of x, which actually in here I have f of g of x. Remember that this means g of x in here is input. Okay, g of x is input. So what does that mean? The output, the output function, the output function was square root of x, right? Square root of x. So now the x was input. Now it changed to be g of x, right? It changed to be g of x. So what is g of x? It was x squared plus 1. So I had to change it x squared plus 1. Okay. Now I come to the chain rule. If g is differentiable at x, and if f is differentiable as g of x, then capital F equal to the composition of f and g is differentiable, and the derivative of fx, the derivative of capital F x will be the derivative of f of g of x multiplied by g derivative of x. Okay, so look like a little bit complicated in here for you guys. Not sure you guys understand yet, but we can extend something over here. So if y equal to f of u and u equal to g of x, and then we can have dy or y derivative respect to x will be equal to dy du multiplied by u dx. So what does that mean here? The derivative of y in respect to x will be equal to the derivative of y in respect to u multiplied by the derivative of u respect to x. Still complicated. I know. Let's try example 12 and see what happened, right? Okay. So I have capital F of x equal to x squared plus 1. In here, I'm gonna let f of u gonna be the outer function, which is square root of u. Okay? So look, square root of u. This is maybe I'm gonna consider this is an u later, right? Okay, so then you will have g of x, which is in inner function. So that's gonna be x squared plus 1. Okay. All right. So now I have f derivative of u. Okay. F derivative of u actually is you know derivative of f with respect to u. So in this case, I'm just gonna have I have to rewrite this as u to the power 1/2, right? I'm gonna have 1/2 multiplied by u to power negative 1/2. Okay. Now for g derivative of x, what do I have? I will have 2 times x equal sign over here, right? So let's come back with the function over here, right? You can have the capital F derivative of x, which is the derivative of capital F with respect to x, will be equal to F derivative of g of x multiplied by g derivative of x, right? So I can rewrite this as 1/2 time with, okay. Now the derivative, I mean the input now is g of x, right? So u change to be g of x. What is g of x? It is, let me use other color. What is g of x? It is x squared plus 1, right? I'm gonna multiply by x squared plus 1. Okay, to power negative 1/2. So remember that this is f derivative of g of x. Right. Now I multiplied by g derivative of x, which is 2x. Okay. So you actually can cancel something come in common. Is 2 and 2 over here. So now you can have the final answer as top should be x. Okay. And you can put x squared plus 1 to power negative 1/2 at the bottom with a square root instead of 1/2. Okay, so that should be the answer. You can also write it as just x over and x times x squared plus 1 to power negative 1/2. That's fine too. But yeah, you can rewrite it as in the rational form with the radical at the bottom here. That's fine too. Okay. So if I talk about chain rule, work from outside in. So I have d over dx, which is the derivative of f over here. F in here is outer function, like I just said, right? And of gx over here, so we is evaluate at an inner function. Okay. So then you're gonna have the derivative of outer function multiplied by the evaluated of inner function, and then multiplied by the derivative of inner function. Oh, there's, sorry, I should say like derivative of outer function that have evaluated at inner function, and then multiply by the derivative of inner function. Okay, so let's we go ahead and go on example 13 over here. I have y equals to sine x squared. We have learned that, notice, sine of x only, okay? Derivative gonna be equal to cosine of x, okay? But in this case, you have sine of x squared. That is composition between sine of x and x squared. So the outer function should be sine of u. Okay, sine of u. And then what is inner function? Just gonna be x squared. Agree with me? So when you try to take the derivative of this, you say like dy over dx is the derivative of y in respect to x. Gonna be d of sine x squared over dx. Okay, so just gonna be the derivative of sine x squared, right? Weight equal to, okay, now this is outer, I'm gonna say this outer, and this is evaluated at inner. Okay, so I have I know that is going to be the derivative of outer, right? So what is the derivative outer? Outer was sine, right? Sine gonna be cosine. So write cosine over here, which is the derivative of outer, and then together with the evaluated at inner, which is x squared. So evaluated at inner. Okay, and then I multiplied by, I need to have parentheses here, and I multiplied by the derivative of inner function. So which is I'm gonna say 2x. I'm gonna write 2x. Right. So derivative of inner which is x squared. So I put x squared here. Derivative it's gonna be 2x, right? So derivative of inner. Okay. So far so good. That should be the answer. Let me circle it. All right. Okay, now I'm gonna move down. And we're gonna try to do example 14. Okay. So let's see. I have y equals to sine x squared. Okay. You can think that this actually like like when you look globally, is actually like a something square, like a u square. I think that's right. So u, right? So so that is what I'm thinking as composition function is gonna be like a u square and psi x, right? So the outer function gonna be f of x and will equal to x squared. And the inner function will be, you know what, I'm gonna change this letter become u so you don't confuse where I gonna have u. So here it is u squared, okay? And the inner function gonna be g of x, which equal to psi of x, right? So now I'm gonna have dy dx, or derivative of y with respect to x will be equal to derivative of psi x everything squared over the x, right? Okay, so weak gonna be firstly is the derivative of outer, right? Derivative of outer function. So which is 2 times with the evaluated at inner. So that is g of x. So sine x to power over to power 1. We got 2 minus 1, right? Which is 1, okay? And then you multiply it by the derivative of inner. So inner was sine x derivative. And that's gonna give me 2 times sine x times with cosine x. Okay? That should be the answer. Okay. Now I would like to introduce introduce about power rule combined with chain rule. Okay, if n is any real number and u is 0x is differentiable, then d over dx, or the derivative of u to power n respect to x, will be equal to, so you see that, it still put down the n in front of u, and then you still have a, a power which lower down 1 unit, and then you multiply by the derivative of u with respect to x. Okay, so yeah, I usually like to see this one better than the one over here, but yeah, you can take a look at that. It's just, instead of u, we write as g of x, right? Same thing. Okay, now let's just try y equal to x4 minus 1 to power 100 over here. You can actually notice that you can have this as a u to power 100. You look globally, right? So you can right away think that you can apply the power rule combined with the chain rule right away over here. See that? So so then you're gonna have y derivative will be, you put out 100, right? 100 put out. You're gonna rewrite the u, which is, what is u in here? Notice that u in here gonna be x4 minus 1, right? So I put 100, sorry, x4 minus 1, right? To power n minus 1, which is 100 minus 1. And you multiply by du or dx, which is the derivative of u with respect to x. So it means what? X4 minus 1, I take the derivative of it. Okay, so one more step, I have 100 x4 minus 1 to power 99. And for the x4 minus 1, the derivative will be multiplied by x4 minus 1, derivative going to be 4x to power 3, and 1 going to be 0. So I'm just going to put like this. Okay, if we want to combine everything, we simplify everything, we should have y derivative of 400 times x to power third and times with x4 minus 1 to power 99. So that should be the answer for this problem. And then I'm gonna just circle this. Okay. Now, example 16. Let's try this one. Okay, so you can see that there's constant in the, this is a rational function, and there is only one, a constant number 1 on the top. So right away, I convert it to make it as a power form, as an exponent form. When you look globally, you see this as in Jews, right? So you can write as u to power negative 1/3, right? And you note that u in this case is x squared plus x plus 1, which is inner function. You see that, right? Okay, so now follow the power rule combined with chain rule. You're gonna have the derivative of x will be equal to um, negative 1/3 put down, right? You oops, now you're going to multiply it by the the inner function is u, x squared plus x plus 1 to power lower than 1 unit, right? Okay, lower than 1 unit. And then I multiply by the derivative of the inner function. So what does that mean? X squared plus x plus 1 derivative, right? And then you will have negative 1/3 time with x squared plus x plus 1 to power negative 4/3. And for the derivative of x squared plus x plus 1, it will give you factor as 2x for the first term, right? 2x. And the second term will change to be 1. Okay, so that should be the answer already. But if you like to write it as a rational form, you can write it as negative 2x plus 1, right? Don't forget the parentheses, divided by 3 times x squared plus x plus 1 to power 4/3. If you like to write it as rational function, you can do that, or you can keep it here. That's fine to me too. So either way is good. All right. Okay, so let's move to next one. I have example 17, which is y equal to e to the power psi of x. This is an natural exponential function. However, the exponent in here is not only an x. It is a function of x, which is psi of x in here. So you can consider it as e to the power u, something like that, right? So then if you take the derivative of it, y derivative, you're gonna still have the same. Remember that's the derivative of, and keep in mind that, note that, right? Note that e to the x derivative will be equal to e to the x itself. But in here, it's not e to the x, it is e to the function of x. Remember that. Okay. So so if you take the derivative of it, you will still have e to the psi of x. Okay, itself. But you have to multiply it by the function of x here, the derivative. That's the reason which got this chain rule, right? And then what is that going to be? Y derivative equal to e to the psi of x multiplied by cosine of x, which is the answer of this problem. Okay. So far, so good. All right. So we're gonna move to the next one. I have a worksheet for you to work on it. Let's see how many I probably have. Oh, that's a lot. Well, I actually That's a lot, but let me see if I can. I will let you guys do this one in class. Okay. And this one too. Okay, that's fine. No worry. Okay. And I will come up with a general rule for differentiating y equal to e to the mx. So that's going to be m times e to the mx. Why is that? Because when you take am when you take firstly is derivative of e to the mx going to be e to the mx multiplied by mx derivative, and mx derivative should become m. So then that's the reason why you have m times e to the mx, right? You can check that later on with some example above. Okay, so last we move let me see. Is there any example? No. I'm gonna leave this for you to on it. And so let's we talk about example 18 over here. So we have y prime y equal to x times ln x. So okay. Okay, so let's do this problem. Okay, oops. All right. So I have y derivative will be equal to so this have a little bit thing that you should know is it have two two factor, right? Which you have like a product in here, so you need to use you need to apply product rule in here in order to do this problem. So you actually do x times ln x derivative plus with ln of x derivative term with x, and then if you let me see, according to above, I haven't write above, but I should note that for you a formula for you that's ln of x derivative let's see. Ln of x ln of x derivative will be equal to 1 over x. Okay. Oh, wait a second. I make a small mistake over here. So I should have x times ln x derivative multiplied by x derivative times ln x. Okay. And now I'm gonna have x times ln x derivative gonna be x times 1 over x plus with x derivative gonna be equal to 1 times with ln of x. So then that will when you want to simplify things, you should notice that there is an x here can be cancelled, and then the answer should be ln x in ln x and 1 equal to ln x. Oh, by the way, it should be 1 plus 1, right? So I should have 1 plus ln x. for the first term. It become 1. All right. This will be the answer for this one. This one I need to use product rule. Okay. Example 19, if I want to differentiate y equal to ln of x cubed plus 2, okay. So this look like I have to do an ln derivative of a function of x. So I can rewrite a function that was u in here. Okay, let's see. U in here, and want to take u in here, right? So you want to take the derivative of this, right? Let me choose. You should know that u in here equal to x cubed plus 2, right? So if you want to take the derivative of y, you're going to have 1 over u, which is x cubed plus 2, right? U in here is x cubed plus 2, okay? And also you need to multiply it by u derivative, which is x cubed plus 2 derivative. So then you have 1 over x cubed plus 2 multiplied by 3 times x squared, don't forget the parentheses, and then plus 2 derivative going to be 0. So just parentheses that, okay. Now if you want to simplify everything, you have y derivative will be equal to 3x squared over x cubed plus 2. That should be the answer for this one. Okay. So now let's let me move down a little bit. And so we did have exercise to try 14 over here. Yeah, and with ln and another problem b in here could be a different a little bit different with a bow, but you should understand this. It has product rule, but remember that there is 3 of x, 3 times x over here. So you will have the combined nation between the product rule and the chain rule. Okay. So let's see, what else do I have? Okay. So the fact that for the derivative of mnx, you're gonna get 1 over x, but the derivative of logarithm base a of x will give you 1 over x times ln of a. Okay. Wow, that's gonna give you we're gonna give you, I'm gonna have exercise to try for you. This is an application for statistic. Well, actually, the main thing in here, you should know that in order to this is a poverty density function. So Yep, it have so many things over here for you. But you should know that the variable in here still is the x, and the rest will be just, you know, constant. So now I also have for the normal distribution, the mean over here. If you learn about if you did learn about statistic, is mean equals 0, and standard deviation over here is 1, and it's giving you this at the probability density function. Okay, this for okay for where a function has a horizontal tangent line. So using the derivative and setting it equal to 0. Okay, so we need to let me see. We need to find the equation of the tangent line. Let me see. Yeah, correct. Yes. Remember that this function has to have a horizontal tangent line. So, firstly, you need to take the derivative first. So y derivative will be equal to 1 over square root of 2 pi times e to the negative 1/2 x squared. Remember that e to the power something derivative itself, but the exponent in here is an equation of x. So so I'm gonna have to take the derivative of it also. So I'm gonna rewrite it as d of negative 1/2 x squared over dx. And so and then I have I'm gonna have e to the negative 1/2 x squared over square root of 2 pi multiplied by okay, so negative 1/2 first multiplied by 2 times x. And if you can see, there is something that you can cancel, such as 2 over here, right? And then finally you can have let me put here. Yeah, you're gonna have y derivative will be equal to e to negative 1/2 x squared. We make it more, negative 1/2 times x squared over square root 2 pi and multiplied by I should have a negative multiplied by x over here. So did I miss anything? Okay, everything's so good. So now because we has the function has a horizontal line, horizontal tangent line, right? So then the slope at this tangent equal to 0. So that means the y prime at that point equal to 0. So So I will have this y prime equal to 0. So I will have negative e to negative 1/2 x squared times with x divided by square root of 2 pi equal to 0. Right? And then since that, then you can right away know that's the top has to be equal to 0, which is negative e to negative 1/2 x squared times x equal to 0. Because if you multiply by square root 2 pi both inside, that you're going to give it as the top equal to 0. Also, you should know that since this is zero factor, and also this part over here is always not equal to 0. So you can, you can just take away it. So answer should be x equal to 0. Only one solution in this case. Okay, and I'm gonna say e to negative 1/2 times x squared gonna be not equal to 0. Okay, so then now I know that's I would say here is y derivative of a better, right? And here's y derivative of a. Right. Y derivative of a. Oh, come on. So what is a function, the tangent function? You should have tangent function is is y equal to y derivative of 0. Here I have x equals 0, right? Which is y derivative going to be y a. What is a going to be? Just 0. Time x minus at x. Okay, so let me so I have in here since x equals 0, I have y derivative y derivative of a equal to y derivative of 0, because x in this case is 0. So then a is just 0 equal to 0. And then I need to have y. Let me write out here as x minus a over a over no minus or plus y of 0. Yes. What we need to have right now is y of 0. What is that going to be? So let's find y of 0. Y of 0 over here. Gonna be equal to what? Since I have y equal to 1 over square root 2 pi times e to -1/2 x squared. So I put x squared now becomes 0 squared. So that's gonna give me y0 equal to 1 over square root of 2 pi, because e to the 0 gonna be equal to 1. Okay, so now you will have y equal to y derivative of 0 is just 0 times x minus a in this case actually 0. So 0 and then plus with y0 was 1 over 2 pi. So square root of 2 pi. So then the answer should be y equal to 1 over square root of 2 pi is the tangent line in this case. This is not a good, not an easy problem. So I just solve it for you. Okay, it's good. Okay, let's move down and see what do you have. I think we just finished 3.4 and 3.6, and I'm gonna stop here, and I hope that um, you understand it. If not, we still have in class, and I'm gonna work on. We're gonna work on the exercise to try, and see you later.